All right. So, welcome to this first lecture on theory of computation. I wanted to give some sense of what we will learn in this subject, and it's a demo class, so it's a good 1 hour session that I will take today. 1 hour, 1.5, whatever, how much time it takes, I don't care for that because I want you to learn something. So I can guarantee you will learn something new today, and that is one of the very important topics in your TOC, and you will learn it today only. And for people who are new, who have not learned from my lectures, I tend to not talk about a lot of technical details on things unless and until I've explained the concept. Um, so you'll get a sense of it today. Basically, my idea is for you to learn things and be able to understand concepts. And once you understand it, once you're able to work on it, then we will actually be. Then I will give you the technical details. So, without further delay, let's begin. 1 second. Okay. As always, this is the demo class for theory of computation. A bit about me, if anyone wants to know, if anyone is interested. Uh, I am Aditya, and I graduated with a master's by research in computer science from IIT Madras. I worked on multi-threading and multi-parallel programming. So I got introduced into the world of compilers, architecture, and through my masters predominantly, because before that I was working as a data scientist in Hyderabad. So yeah, so I currently work in a company named NVIDIA, if you have heard of it. So I work in NVIDIA as a full-time compiler engineer. Many of the concepts that I teach you on architecture and compilers, they directly I use them in my day-to-day work. So you will get to hear a lot of real life scenarios, real life things when we try to learn them. Okay, so let's start the topic, and I guarantee you will learn something new today. This is a topic that is taken from the middle of the syllabus, but I'm sure you will learn. Okay. So again, also one more thing is I want my classes to be interactive. If you are shy enough to not speak out on the mic, I would want things. I would want the chat window to be used as much as you can, and please do not hesitate to ask any question. So before I begin and before I start talking about TOC, how many of you know something called a string? Maybe it's a concept in C. And what is a string in C? You might have heard about C in C programming, C++, or Java, or Python, whatever you say. There is something called string. What is the meaning of string? String is a sequence of characters, or you can say a collection of characters, whatever you say. Sequence would be a better word because it's actually ordered. Okay? If you say sequence, it means each of the elements, they are ordered. For example, one of the strings is gate. Okay? Gate is a string. It is a sequence of characters. Okay. Now I will restrict my space and say that any string that you form, for example, if I ask you a string, you will just give me any string that is possible. I will restrict the letters you can use. You cannot use letters from A to Z. You can only use letters small a and small b. You might ask me why. My answer is this is my choice. Okay. So I just want you to, I do not want to give all the letters as choices. You can construct a string of any length, but you are only supposed to use these two characters. Okay. Is that clear? First of all, if it is clear, can you give me an example of any string that you think of using only these two characters? That you can form using only these two characters. Double A, double B, very good. I have one. I'll write all of them one by one. So double A, double B, I have A, B, B, A, I have A, B. Anyone else wants to pitch in? No? Okay. So let me write one more. You guys tell me whether this is a string or not. AC. Is this a valid string? Valid meaning, is this string can you write? Because again, I told you, you cannot use any other letter except A and B. I use C here. It's not allowed. So this is not a valid string. So I'll just use maybe BA. BA is one of the other valid string. Let's keep these 4 strings as it is. And these strings I was able to form using these 2 symbols. And now let's go into technical details. This set of symbols is called a alphabet. And it is denoted by this sigma. This is also called a alphabet. And this individual A and B, they are called symbols. Okay, so basically, you have given your set of symbols, which we call the alphabet. Using the alphabet, you can form different strings. And these are the 4 example strings that we were able to form. Okay, so far so good, everyone. I will explain later why are we reading this, why is it related to TOC. I will look into that later. Not just think of it that I'm teaching you something now. Okay. Okay. Is it okay till now? Okay. Now, what I want to do is I define something called a language. I mean, you have different types of languages like English, Hindi, Gujarati, Bengali. Each of them differ in some rules they apply. For example, English has something called a defined set of words. You cannot say anything you want to. So all the words or all the strings that you can form from the English alphabet, it is not the case that each such string is valid. For example, if I today ask you, what is the meaning of this? This is a string that you can form from the English alphabet. But as far as I know, this has no meaning in the English language. What does it mean? It means, given the set of strings that you can form, I form a language, I call it L. This language consists of those set of strings that follow some criteria. Or you can also say this language is the set of all those strings that have some meaning. Okay. For example, if I ask you, let's say I write a string like this. Is this a valid string from the alphabet that I have just said? Yes. If you consider this as a valid word in the English language, does it have any meaning? There is no meaning of this word. At least I don't know the meaning, and I am sure there is no meaning even if you look in the dictionary. So we can say this is not belonging to the language, and I will just write English here saying it does not belong to the English language. Okay, so one thing that again you will understand it later, but I'm just stating it now. It's a bit technical. You can form any number of strings from this sigma. You can form any string, any length, 100, 200, 10 length, 5 length, 4 length, 3 length, 1 length, 6 length, whatever length you can form. You can form a lot of strings from these two symbols. So, but in a language, it consists of a subset of these strings. I hope you all know what is the meaning of subset. And later on, I will also say that some of the topics in this course, they directly follow from discrete maths. So if you don't, and if you have problem, if you struggle in understanding those concepts, do let me know. I can elaborate it further. Okay. So anyways, let's come back. All the strings that you can form from the alphabet, a language consists a subset of those strings. Okay. Okay. Now what I will do is, I will define one language, my own language, from the same alphabet. So the alphabet again is a set of symbols. I will consider them as A, B, like same as earlier. But I will form a language. Okay. And again, as I say, the language is nothing but a set of strings with some criteria. I will write the criteria like this. Strings starting with A. This is a language I have designed. This is a language that I define, which consists of all the strings that start with A. What does it mean? It means all the strings that you can form from sigma. This language will contain those strings that start with A. So again, to make it interactive, can you tell me any string from the language? See, for example, you told me some strings in the last slide. You told me A, B, B. You told me A, B, B, A. You told me A, B. I gave B, A. So are all these strings part of the language, L1? Do all of the strings start with the letter A? No. Which string does not start with the letter A? BA does not start with letter A. Very good, Akash. Very good. So now let's come back. Can you give me some example strings from the language? The language I have defined strings that start with A. One thing can be very simple. It can be single A. This is a string that starts with A, ends with A, right? A single A. And Akash gave a good string, so we'll use that as well. He gave A, B, A, B, A, B. Good. That starts with A. Any other strings? How about A, B? How about A, A, B? How about A, B, B? And so on. So how many strings you could possibly make that start with A? What is the number of strings that you can make? Infinite. You can make as many strings you want. Any string that you want, there are infinite possible strings that you can create from A, B. And if you take a subset of those, which is the strings that start with A, you can form infinite number of strings. So we have defined a language. Okay. Okay. Is there any question so far? Defining a language, defining an alphabet, defining a string. Any question so far? We are learning things. I will go later. Okay. What we are learning, I'll teach you later. Don't worry. Just listen to me now. Okay. Now I give you one problem statement. So we have defined a language, and I will give you one small problem statement, which is this. See, you need to design a method, or you have to design an. You all are, I guess, computer science students, or maybe people who have learned computer science and have come across a term called algorithm, which is a method to solve a problem. So basically, you will have to find a method, or in other words, I can say algorithm, that does something like this. It takes as input a string. And in theory of computation, in TOC subject, all the strings are denoted by a letter W. This is the convention that is not like on stone, but each of the book in the exam, everywhere they say W as a string. So that's why I used W. What your job is, you have to find an algorithm that takes as input a string W and it gives as output either yes or no. And when does it say yes? If the string W belongs to the language. For example, if W is a string that starts with A, this algorithm should print yes. Otherwise, it should say no. Is the problem statement clear? Is the problem statement clear, everyone? Basically, you have to find an algorithm that takes as input the string W, and maybe you can also say it takes as input the language, because obviously you want to tell which language you want to check. And it outputs a yes if the string belongs to the language, otherwise it outputs a no. Okay. How do you solve this problem? For example, I will give you few solutions. You will have to tell me whether these solutions are okay or not. You can say it's not okay. I mean, purposefully, I will give you bad solutions also to try to understand whether you are understanding things or not. So one solution that I can give you is you can store. So for example, if I were to write this algorithm on a computer, right, on a PC, what I would do is I would store all the strings in the language in memory. So what I will do is all the strings that are present, I will store them in the memory. Okay. Now, if there is a string W and I want to check if W belongs to the language L1 or not, I will just check, I'll just do a find whether this W is present in memory or not. I have stored all the strings from the language L1 in the memory. So I just have to check, is W one of the strings in the memory? If it is, I output yes. If it is not, I output no. Does the solution make sense? One of the solutions. Basically, you just store all the strings in an array, store it in a memory, given a string W, find it in that array. Hey, is the string present here? Is the string present here? If it is, print yes, otherwise no. Arshi has asked a very good question, and that is the answer. So, okay. How many of you say that this solution is okay? I mean, this solution is good. What do you comment on? Arshi has already given a question, which is where I'm going into. So maybe the hint is just look at Arshi's question on the chat. Is it possible to store all the strings of the language in memory? Do you have infinite memory on your CPU, on your computer? Can you store infinite number of strings in memory? I mean, do you use your computer for that? Obviously, you use it for much better things, but certainly you won't use it to store infinite number of strings because you cannot do it in the first place. Okay, so this solution is not good, right? This solution is not good. What else can I do? What I can do is I can do something like this. See, and again, be very careful and be very clear with the fact that what is your problem statement? The problem statement is, given a string W, given a language L1, can you write an algorithm or a method that prints yes if the string belongs to L1, otherwise it prints no. Okay, the problem statement should be very clear. Okay, so let's go to the next and see. So this solution does not work. Storing all the strings in memory, how will you do it? There's no possibility, you cannot do it in the first place. Here comes something called finite automata. And don't be afraid of the term finite automata. I know why. I know people get afraid. I don't know why, but okay, don't be afraid. Basically, what it is, I'll give you one algorithm on how to solve. Okay, what we will do is we will draw something called a state machine. And again, state machine also might seem a bit difficult term, but everything will be as smooth in some time. Okay, I'll take one example string. Okay, suppose I take a string like this. Some example, any string I took from the alphabet A comma B. My first question, is this string part of L1? What do you think? Good, very good. What I will do is, I will have a pointer to the first character. And when I have not, when I as in, when the pointer has not seen any input yet. What do I mean by it is, when the pointer is pointing at this location, that means you want to read this character. In this case, it's an A. The pointer is just which character do you want to read at that moment. Okay, it's similar to your concept of C. If you have an array of n elements, you write I equal to 0, I less than n, I plus plus. You write ARR of I. Now, what is ARR of I? You're basically indexing, reading the value at the ith index of the array ARR. Similarly, I have something called a pointer which points to a character that I want to read. And let's say I am the machine. Okay, I am the machine and I want to write an algorithm, or I want to simulate in such a manner or design a machine in such a manner that I will read the entire string from the first character to the last character. I will read it entirely and then I will decide whether this string belongs to the language or not. Okay, so how will I do it? See. So initially I have not read any character. My pointer is pointing to the first character and I have not read anything. So initially I am at a state called the initial state. What does it mean? It means that I have not read anything. Okay. Okay. So I'll just add an arrow here. We'll understand why later, but just I'll add it here. Later we'll understand. Now, when you are in the initial state, when you have not read any character, given the language L1, which is strings that should start with A, what is the first character that you are expecting to read? A. Everyone? Initially, when you haven't read anything, you want to make sure that which is the first character that you want to read? You want to read an A. Because if a string starts with A, the first character you want to do is read an A. So what you will do is, when you read an A, you go to a new state because you have read one character. So now your pointer points to the next character, which is B. And here you go to another state. I will call it Q1. Okay, so far so good. Okay. Achha. Now tell me one thing. From the initial state, you reached Q1 because you read an A. Now, if you are in the state Q1, you as in the machine, you're trying to simulate, you're trying to read the string using the pointer, and you're maintaining your state. Initially, you did not read anything, so you were in the initial state. I call it QI. You read one A, you went to Q1. Will you accept the string when you are at Q1 or reject it? Or you don't know? What do you think? You, as in the machine, if you have reached Q1, will you accept the string? Will you reject the string? Or will you say that I want to see more input, I cannot decide right now? Based on the language, what do you say? What do you answer? If you are in Q1, why did you reach Q1? Because you read one single A. Initially, you read one single A. You reached Q1, which means you know that your string starts with an A. So will you accept the string or will you reject the string? You will accept the string. Okay. So to say that this state is an accepting state, or if you land in this state, you will actually accept the string. I will draw two circles. Okay. Now tell me one thing, one more thing. You have read one single A. Okay. Based on the language, do you want to, so whatever be the rest of the string, will you still accept the string or reject the string? For example, you read a single A, so you went to Q1. After A, if you read anything, does it matter? You will basically accept the string still. So at Q1, if you read either A or B, anything you read, you will stay in Q1. And once you have read the entire string, then you will say that I accept the string. Now, if you don't understand, let me run it through an example. Okay. So let me run it through this example, A, B, A, A, B. Initially, I am here. My pointer is pointing to this location. You read an A. You went to Q1. So at this point, you were in QI. Then at this point, you went to Q1. Then you read a B, you read an A, you read another A, you read another B. You stay in Q1. Why? Because you have this loop here. Once you have read the entire string till the end, and you are in an accepting state, in this case Q1, you will accept this string. Does it solve your problem of how can I draw a machine, how can I design a machine that will help me to accept a string? How to reject, I will talk later. Don't worry. It will be just a very small addition to here, this diagram. So again, I told you when you were in the initial state, you read a single A, you went to another state Q1. In the initial state, you could also read a B. I mean, you would reject this string because it does not start with A, but you also have a job to reject the string, right? You just can't say that, hey, it starts with A, I will accept. Your job is, if it does not start with A, you have to also say no. You have to reject it. So we have considered the possibility that from the initial state, if the first letter is a A, then I go to another state Q1, and whatever I do in Q1 is after I read an A. But from the initial state, when I have not read anything, there can be a B also. So if the first symbol that you read is a B, will you accept the string or will you reject the string? You'll reject the string. Very good. But somehow that is not reflected in this diagram. Let's reflect it. So if there is a B, I go to another state called Q2. And tell me one more thing. After B, if there is any sequence of characters, will you ever accept it? So you will add a self loop here, saying no matter what string comes after when you read a single B and move to Q2, whatever comes after that, I don't care because I have already rejected the string. I will just keep on reading those strings, those symbols, and once I have finished reading the input, for example, let's just take an invalid input, BAAB. It's an invalid, it's not a part of the language. Once I have read the entire string, I land in a state which is not an accepting state. Q2 is not an accepting state. Everyone now should know why it is not an accepting state. Right? Everyone clear with that? Why Q2 is not accepting state? Because Q1 has two circles, if you see. Q2 has a single circle, which means it is not an accepting state. So once you have finished reading your input, the final state that you are in is not an accepting state. If that is the case, sorry sir or sorry ma'am, I will have to reject the string. Okay. Any questions so far? No? Okay. See, how to draw these machines, it will take time. For example, I will deliberately do one mistake in the diagram. I will deliberately do it. Your job is to tell me what is the mistake I did. Okay. So let's keep the valid diagram here. So the valid diagram, I'll just keep it here. Okay. The best way to prove that these diagrams that I'm drawing are incorrect is just take an example and run it over the machine. Okay. So see, suppose I am in QI. Okay. If I read an A, I go to the accepting state. I mean, it goes to the accepting state. That part is okay. And then what I understood is somehow I do not want to go to a new state when I read a B. See, my QI is also not an accepting state. My QI is not an accepting state. So why do I need to go to a new state? I can just loop around here if I read a B. Which means if I read a B in QI, I will stay in QI. What is the problem with this machine? I will ask you in a slightly different manner. If there is a string called BA, okay, initially you were in QI. When you read a B, which state will you be in? Look at the below diagram, not the top one. The below diagram, when you read a B, which state will you be in? QI only because there is a loop. right? You'll stay in QI. Then you read an A. Which state do you go to? Yeah, I mean, this is how I have designed the diagram, Akash. So if you read an A, you go to a new state. Not the next state, maybe new state. You can also come back to the initial state. You can draw the edges as you want to. But yeah, if you read an A, you go to a new state because QI means, based on the language, you have not read anything. A is a state, Q1 is a state, which means that you have read at least one A. And the first symbol that you have read is an A. That's why you go to a new state, because your state has changed. You're not in the same state that you have not read anything. Okay? You are basically moved to a new state. Okay. Later on, when you do more and more questions, you will understand it better. But we'll do today some more questions as well. Okay? Let's come back. So if you look at this diagram, I had the string DA. If you read a B, where do you go to from QI? You come back to QI only. When you read an A, which state do you go to? Follow the arrow from QI. From QI, on reading an A, which state do you go to? Q1. I have finished reading the input. I have landed in a final and accepting state. So that means I am accepting this string. Is this part of the language? Did you understand what happened here? For example, if the same input I ran it on the correct diagram, for example, I ran it on BA. I am in QI. I read B. So which state will I go to based on the correct diagram? Follow the edge, Q2. I go to Q2. Then if I read an A, which state will I go to? Q2 again. Is Q2 an accepting state? Do you understand the mistake that was done here in the below diagram? What is the mistake here? Did you understand? See, in the above diagram, when you have read a B, you basically do not have a choice, which means you cannot go to the final state by any manner. There is no edge like this, right? I mean, once you are in Q2, you cannot go to the final state. But in the below case, even if you read a B, you can still go to the final state. Okay. Any questions? Others? Any questions? So I will gradually increase the difficulty. Okay. And let me know if difficulty is going too high. Okay. I will gradually increase the difficulty. Okay. So this is one machine that we designed for this language. And formally saying this machine is also called finite automata. The name is that, just feels cool to say that. That's why you can say it. But yeah, it's nothing, just this diagram, that state machine that we have drawn. Okay. Okay. And we will draw a lot of state machines when we do the lectures. Okay. Let's design another language, maybe another machine. And this time I will say that the language is L2 and it consists of the strings, starting with A, B. Okay. And to design these machines, I will give you some ways to do so, how you can think them. I mean, this all requires practice. There is no shortcut. But I can give you ways of how you can design. For example, Let's take this language that I have written, strings that start with AB. Can you tell me what is the smallest string of the language? Smallest in terms of length, AB. Everyone agree with Akarsh, Sneha? Everyone agree with Akarsh and Sneha? Smallest string is AB. Okay? Any other string? Maybe ABA, maybe ABB, maybe ABAB, maybe AB, ABAB, and so on. Yeah, A triple B also. There are many. Okay, you can form infinite number of strings. So what I do is, again, this is my way of solving it, and it works always. Draw the diagram that accepts the smallest string of the language. What is the smallest string of the language? AB. So, starting from the initial state, draw a diagram that first reads an A. You go to a state called Q1, and then you read a B. You go to a state Q2, and this time you will accept it. If you understand this diagram carefully, this string will accept AB. Again, this is how I design. Okay, you can have your own method as well. Okay, but this is how I do. Get the smallest string, in this case AB, and just draw the finite automata with those many states such that AB is accepted. Okay, so far so good. Any questions? Right? No questions with this diagram. Okay. Now, you look at each state one by one. For example, let's look at QI. I see that QI, I have given a transition for A, but I have not given a transition. So these edges that I draw is called transition, okay? These edges from one state to another, all of these are called transitions. So I have designed it for A from QI. How about B? First, let me ask you this. We'll draw it in the machine later on. If you are standing in QI, which is you have not read anything, and you have read the first symbol as B, what will you do? Will you accept the string? Will you reject the string? What will you do? Or you need more input? Reject it. Good, very good. So, similar to how we had drawn earlier. What the hell? 1 second, sorry. Yeah. So from QI, so B, you go to a state. This state has a name called QD. I will tell you later what is QD. I just wrote it as QD. You can call it anything you want. Q IGC also works, but I'll write QD for now. Let you know what it is later. And if you have read the first symbol as B, there is no possibility that you will go to the final state. So you will be stuck here forever. Similar to how we had done for this case. When you read a B, you went to a state where there is no exit. You will stay in that state forever. You will stay in Q2 forever. If you reach Q2, you are in Q2 forever. And this D here stands for dead. It's called a dead state. It's a name given. I mean, just it's a name. Okay, dead state means a state which you cannot exit from. Okay. So from QI, I have designed transitions for both A and B. Now I see that from Q1, I have not designed a transition for A. First, let me ask you a question. Why did you reach Q1? Which symbol did you read first such that you reached Q1? A. After an A, you read another A. Is this allowed in the language? So what should I do? You tell me the transition. From Q1 on an A, which state should I go to? Another dead state is not required. You can go to another dead state, Akash. That's a very good point. I mean, you are saying I can, which is correct as well. You can draw this as well. Okay. But typically what happens is in machines, right? You want to optimize things as much as possible without creating redundant states. There is already a dead state existing. So maybe I can just use the same one and design a transition from Q1 on an A to Qt. Is it okay, Akash? But very good point. I think you actually started talking about minimal DFA and all. So I'll go to that later on. But we're just trying to do a demo class today. Okay. So okay. Okay, I have designed the transitions for QI. I have designed the transitions for Q1, but on Q2, I see there is no transition defined. From Q2, again, why did I reach Q2? Because what have I read such that I reached Q2? I as in the machine, AB. So after AB, no matter whatever you read, does it matter? So whatever you read, you will stay in Q2 only. Is this clear? Okay. Let's do another problem, okay? And then I'll just give you a hint on what is the syllabus about, what we will learn, and then we'll end the class. Okay, I'll give you if you have understood all these things, how to draw a finite state machine, again, formally, I will teach you, there's a lot of things to teach here. I'm just giving you the most interesting parts. And I'll give you one question to solve. You can do it on your free time. It's an important question for the gate as well, but we'll go to that later. I'll just give you as homework. Okay, if you want, you can solve. You can share your solution with me on WhatsApp as well. And please try it. Make mistakes. It's absolutely okay. Okay, please make mistakes because you will learn then. If you are able to do it in one go, tab to good, very good. Otherwise, please make mistakes so you learn. If you don't try, then there's no scope of learn. So okay, now I will draw some other language. Okay, and this time the language is slightly complicated. Okay, now what I will say is another language which consists of strings that end with a. We looked at strings that started with a. We are looking at strings that end with a. My same question again. Which is the smallest string that you will accept for L3? Single A. And some other examples. Maybe something that was not in the previous language starting with A. ABA is also in the previous, something that is not in the previous language. Maybe BA. BA is a string that ends with A, right? Maybe BABBA, string that ends with A. And I don't care if it starts with anything. I do not care about that. It ends with A. Is the language clear? Abhiram, good. Very good. Is the language clear? So again, follow my same technique. First, let's make sure that the smallest string is accepted. So QI I will make it read an A, and I will reach. So there is another name for the accepting state. It's called final state. So I call it QF. But again, it does not matter. You can name it anything you want. The thing that matters is any accepting state will have this concentric circle. Okay, that is what is matters. Okay, now it's very interesting, guys. From QI on an A, I reached a final state because I want to accept A. What if there is a B? Will I go to dead state? Think. Think of it in the sense that if you read a B initially, for example, if I read a B initially, my first letter I read is a B. After the B, I can have an A. This is a valid string, right? This is a valid string in the language. After a B, I read an A. So do you want to go to the dead state? See, if you go to the dead state, you basically are saying that I do not accept it. There's no way you can go to the final state. So on a B, you maybe would not want to go to the dead state. I can say that I will go to another state. And from here, if I read an A, I go to the final state. Is it clear? Is it clear, everyone? We have drawn some parts of it. I will elaborate it later. Okay. So on Q1 is a state where you read a single B. You can read multiple Bs as well. This is also a valid string. Yes or no? But if you consider this diagram, current diagram that you have drawn, this input is not considered. So what will you have to do? I maybe can add a self loop in Q1. Very good, Akash. Very good. So now I have handled these possibilities. Now let's look at QF. From QI, on both inputs, I know where to go. On A, I go to final state. On B, I go to Q1. On Q1, I know where I have to go. On an A, on a B. But QF I have not yet designed. Achha. So why did you reach QF? You reached QF because your string ends with A. Maybe I will take an example string. Maybe this is one of the reasons why. Oh, sorry. Maybe this is one of the reasons why you have reached QF. Okay? You will understand later why I erased it, but yeah, just hold on to it. So BA is one way you can reach QF. Suppose you read another A. Does the string still ends with A? Suppose you read another A. Does the string still end with A? So what should I do? If I am in QF and I read an A, I should stay in QF. Very good, Akash. Be confident, no question mark. I don't like question marks. Be confident. If you're wrong, it's okay. You're absolutely correct. But what to do for a B? For example, see this case. Suppose I have a string like this. I reached QF. Then I read a B. What will you do? Dead state or something else? Let me give you a hint. You have only read it till here. It can contain something else later also. So if you are in BA, which is here, in this case you are in QF, and you read a B, Can a A be also there just after this? So what I will do is I will come back to the initial state. Alternatively, you can also go to Q1 from QF. Both is okay. I think better it will be to go to Q. Can I add B on QF as self loop? Very good question. Let's add it. This is what you are saying, Fatima? Arshi, sorry. Okay. Acha, tell me one thing. If you have a string like this, is this string part of the language? Initially, you are in QI. You read a B, so you go to Q1. You read an A, which state you go to? You go to QF. On reading a B, you stay in QF because you said you will do self-loop. You have read the entire string and you are in a final state. So I'm accepting this string. Do you realize what is the mistake? You are saying this string is not accepted. Then this finite automata is accepting this string. So something is not correct, right? So what do you have to do? To fix it, you have to come to a state where you have read a B and the next input you are expecting is an A. And for example, in BAB, in the correct case, after you read B, you stay in Q1 and Q1 is not a final state or Q1 is not accepting state. You say that you reject the string. Do you understand? Again, it will come from practice. Let me tell you, it will come from practice, but you can optimize this or minimize this also by drawing this TFL. You are in the initial state. You read an A, so you go to the final state. Nothing changes till now. Okay. Inside the final state, if you read an A, you will just loop. Okay. In QI, if you read a B, you will self loop. Basically, you are saying I do not care about B's if they start at the beginning. Only when I reach C and A, I will go to QF. And from QF, if I read a B, I will come back to QI, expecting that the next input I will get is an A. This is the minimized form of the above machine because it consists of lesser number of states. The way to understand this is take more and more example inputs, run over the exam machine, and you will be able to understand it better. So far, so good. Everyone? Any questions, any concerns, any doubts? Okay. So we are here, and again, so let's now talk about the subject. And TOC, or theory of computation, is a study of these languages and how you can design machines that accept these languages. And for example, okay, so every one of you here have heard about C programs, right? You write a C program. Let me ask you and tell me from your imagination, when do I say that a C program is valid? What is the meaning of a valid C program according to you? Yes, I need answers. It can be creative. You just answer anything. It's absolutely okay if you're wrong. Be creative. What is meant by a valid C program? Getting the desired output. Okay, very good. And what else? What is the very basic thing? Yes, Abhiram, very good. And Abhay, very good. So Abhiram and Abhay are actually saying something called they follow a desired syntax. What does it mean? Let me ask you this way. Do you mean by desired syntax that there is a language that is defined for the C program, how to write a C program, and your program should adhere to that language? Is that what you mean by syntax? See, how to write a C program? There is some way to write a C program. For example, is this a valid C program? I mean, just think of everything is written. Why is it not valid syntax? Who said it's not valid syntax? I mean, this is not valid, I understand, but does it mean that you're not following the syntax? That's what I want to ask you. Why do you say it's not valid? Because it does not follow the syntax. It does not follow the representation of the language that is given for the C. If you want to write a C program, what is the language to write a C program? This does not adhere to it, or it does not follow the correct syntax. Now let me ask you a question again. You have a machine. You want to design a method that takes as input a C program and prints if it is valid or not. It prints yes if it is valid. It prints no if it is not valid. How will you design these machines? Now there is a software that exists that also checks the syntax of the C program. Does anyone know what is that software called? Compiler. Now compiler is an application of theory of computation. So I often give this as prerequisite that TOC is a prerequisite for compiler. This is the reason why it is. If you want to find if a program is valid or not, you basically need to design machines, design methods or algorithms that prove whether a C program is valid in terms of syntax or not. And this is all the concepts of compiler that have been implemented have been motivated by TOC. Okay, it's one of the applications of TOC. Okay, so we will learn more and more about TOC. For example, let's go over the syllabus now. Okay, so this is directly taken from the the Gate website, and this is the syllabus. First, you have to go. We will study something called finite automata. We looked at it from some aspect today. Some part we looked at it today. Okay. Now there is one way to represent a language using expressions that is called regular expressions. Few of you might have heard of this term, maybe if you are programming geeks, but it's okay if you have not. Don't worry about it. Then we will move on to something called push-down automata and context-free grammars. Again, please do not be afraid of these terms at all. It's very simple. Okay, I will explain everything. Don't worry as we progress. And then we will go to regular context-free language, something called pumping lemma. It's a theorem. Then we'll finally finish it with Turing machines and undecidability. This is the basic syllabus of your TOC, and it will be a fun thing, fun journey. And one thing that I will tell you is this topic requires practice. You have to be thorough with your concepts on. Uh, Sorry, you have to solve more and more PYQs on. Uh, Sorry, you have to solve more and more PYQs to get a better hand of this subject. So make sure you do it. And in case you have time, you want to read a book, there is one book called An Introduction to Finite Automata by Peter Linz. I would recommend you to, once you have learned the concept of how to draw finite automata and how to write regular expressions or etc., there are a lot of very good questions given in this book. Just get a PDF of it, and you can solve them. And if you have any problem, do not hesitate to ask me. I also share my WhatsApp number in case people want to talk to me, want to ask me doubts. And also, I'll give you one homework question today. People who are interested may talk. When I teach you, I'll anyway do those questions, but I'll still want to give you this as homework. So, okay. Okay. Your homework is this. See. Okay. So, how many of you here know binary number system? Okay. So, what are the symbols that you have in binary number system? What are the digits that you can use to make a binary number? 0 and 1. So, I define the alphabet as 0 and 1. The language is all the bit strings. So, what is bit strings? The strings that you can form with this 0 and 1. Right? All, you can also write all strings. I just wrote all bit strings whose decimal value is even. For example, 4 is an even number, right? It has some binary representation. I won't write it or else you will get the solution. It has some binary representation. 3 is a odd number. It has some binary representation. Some set of zeros and ones, some bit string. You feed this as input to your machine that you have drawn, the finite state machine that you have drawn. I call it FSM. If it belongs to the language such that the decimal value is even, you would print yes, otherwise you print a no. Do you understand what I am asked? The hint is write the binary representation of a even number, an odd number, and that should be enough. You will understand what I am asking. Okay. Before I end, any questions regarding today's lecture? No? Okay. I'll just quickly share over the slides for you to see, learn. Uh, And see you guys in the lectures. We will start, and gradually we will do more and more of this problem solving, and we'll learn together. Okay. So thanks for joining, guys. It was a short lecture, but just a demo on TOC. We'll formally look into the things. You can wait for the slides to be available. Okay, you should be able to see the slides. Thank you for joining. See you in the live lectures.